Hello and welcome, everyone. I'm Dr. Dustin Kieschnick. I'm your professor for this class, Psychology, Research Methods, and Design. And so today's lecture, I really wanted to, it's a shortened version. I wanted to go over some really, really important parts of the week of chapter 2 of getting started in research. I'm not going to cover the entire presentation that you have in Canvas, but what I am going to do is the slides that I have are going to be a little bit different than what you have, but I wanted to go over them and really talk to some of the concepts that are going to be really important for you to have and understand as you go through this class. They're going to be super foundational, and they're also the topics that students tend to have a lot of trouble with, or or just more difficult, or maybe they're just more challenging. And so I want to provide as many examples, talk to it as much as I can so that it starts to make sense for you. All right, let's dive right in. Let me get, if I can get my slides to go forward. So what is a theory? A theory is more like a scientific law than a hypothesis. It's an explanation of a set of related observations or events based upon proven hypotheses and verified multiple times by detached groups of researchers. All of that really says that a theory is really just a lot of evidence that's compiled together. Perhaps it's from a lot of different studies that have been replicated, studies that have shown basically the same phenomena. In essence, it's a hypothesis that's been repeated and tested over many different times. It's a collection of hypotheses that have been tested. Theories are broad explanations of predictions concerning phenomena of interest. So the idea that people are basically good, backing that up with research. People's behavior is motivated by self-enhancement. It's not just something we say, that we have research studies. We have a lot of research studies that point to the same outcome, to the point to the same thing. That's what makes it a theory. If we think about hypotheses and predictions, I'll say this first. A good hypothesis has a prediction as part of it. So keep that in mind as we go through. But a hypothesis is a tentative question waiting for evidence to support or refute it. It's an educated guess based on an observation, but I feel like saying it's an educated guess kind of takes a little bit away from it, because it is actually quite powerful. And it's much more powerful than I'm just, hey, I'm pretty educated and I'm guessing that this is going to happen. It takes a lot of design, a lot of thought, a lot of refinement. It is a rational explanation of a single event or phenomenon based on what's observed. But it hasn't been proven yet. It's about to be tested, but it hasn't been proven. That's the key point. Most hypotheses can be supported or refuted by experimentation or continued observation. So the prediction part of it is a statement that makes an assertion concerning what will occur in particular research investigation. So it says, I predict that this behavior is going to happen if these variables are present, or if these variables are present, this outcome is going to happen. In research, what we're trying to really do is we're trying to predict. We're trying to predict the future. We're trying to predict behavior. We're trying to predict outcomes. We're trying to predict what happens. And we do so just by studying variables and studying their relationship to each other. Now, psychological research is the same as any other research. But research itself is the systematic inquiry aimed at the discovery of new knowledge. It's a systematic approach, right? We have rules for research. We have research that if it meets these certain standards, or certain criteria, it can be referred to as evidence. It basically becomes evidence. But then how do we measure concepts in psychological research? So think of the definition of hope. What's your definition, right? The dictionary's definition of hope is to cherish a desire with anticipation. Or if we think about politics, What's your definition of politics? The dictionary's definition, well, there's three of them. One is the art or science of government. Two is the art or science concerned with guiding or influencing governmental policy. And the third is the art or science concerned with winning and holding control over a government. So then ask, do these definitions provide enough to test? Obviously, the answer is going to be no, but think about what it's missing. What's missing in this definition that allows us to test it? That's where operational definitions come in. Because in operational definitions, we turn ideas into measurements. We turn concepts into measurements. We take them beyond their definition and we basically say how we can observe or measure them. Now, in psychology, we study invisible things. Stress, intelligence, happiness, aggression. I might be able to see that somebody might be stressed, but I can't infer just from that their level of stress. I can maybe infer that somebody's happy or that somebody is experiencing happiness, but I can't necessarily say for certainty which level that's at or compare it to another person. You can't directly observe the invisible things that we study. Now, an operational definition, when applied to data collection, is a clear, concise, detailed definition of the measure. The need for operational definitions is fundamental when collecting all types of data. It tells you how to collect your data. It tells you in what form. Operational definitions should therefore be made before the collection of data begins. You have to know what it looks like before you collect it. If we apply that, let's take a concept, stress. What are the options for us to measure it? How do we measure it in practice? We could take the level of cortisol, which we know from a lot of studies is associated with stress. It's a stress hormone. Heart rate. We know that from studies, elevated heart rate can be associated with stress. Subjective survey score of stress, or skin conductance. We know that we've learned from studies that skin conductance can be an indicator of the body's physiological response to stress. So that's why operational definitions matter, and I'm going to go into why they're so critical. One is replication. It allows us to replicate research findings. Two is objectivity. It allows for objective rather than subjective definition of variables. Once we figure out how to measure it, it then becomes objective, right? Scientific communication allows everybody to be on the same page about what the definition of a concept really is. Even if you think about it in a different way. Scientific having the same operational definition or being able to utilize operational definitions allows us to see and everybody for everybody to speak the same language. Now, operational definitions are choices. Concepts do not equal measurements. Just because you have a definition doesn't mean you have a measurement. Measurements are what allow for the research to happen. So let's look at an example, stress. There are multiple ways to measure the same concept of stress. For example, we can measure by self-report scales, biological markers, behavioral responses, like I mentioned in the slide before. Now, none are inherently right or wrong. They're just different ways to measure the concept. But defining them allows other folks, other scientists, to take those same definitions and measure them in the same way so that we can have replicability of studies. So, but it has to be a measurement for it to be defined as an operational definition. So let's also look at who we study. We can term folks that we study participants, subjects, respondents, informants. The APA, the American Psychological Association's preferred term is for humans taking part in a study is participants. So when you're able to, I suggest you probably utilize that nomenclature. Let's also think about where ideas for research come from. They can come from common sense, from observation of personal and social events. They can come from theories that have been developed. They can come from past research and just from practical problems that come up. You see a problem and you realize, okay, I wonder if there's a connection here. We also want to take a look at the scientific method of idea generation to new knowledge. So we start with an idea, we generate a hypothesis, we design a study, we conduct the study, we analyze the data, we interpret the results, we report the results, and that's when we put it into a manuscript and get it published. Then we also refine the hypothesis, and it becomes new knowledge by going through this iterative process, right? So other folks that are maybe going to do a study after us, they see our results, they see our findings, refine their hypothesis, they run a study, and over time, it becomes not just one study saying something, it becomes a body of knowledge. But let's first take a look at the first three steps here. And we have a multi-step process that really illustrates in detail what this should look like. So going from idea to going from a basic idea to generating a hypothesis and then designing a study around it. So step one, the initial idea. Now this one's going to be incredibly broad. The psychological research often starts with something that you observe in daily life. And the idea is not going to be a formal question. So let's use the example here. Students seem more stressed and distracted when they constantly check their phones. This is not research yet. You're just noticing. Like you're saying, hey, this seems to be an issue. Like students seem more distressed and distracted when they constantly check their phones. At this stage, we haven't defined any variables. There's no prediction. There's no way to test it, but it is a seed. Then we go to the library and we do our research. We do our literature review. We look up research articles. Has this been studied before? What did they find? Are there studies that relate to other parts of my idea? So like, is there anything related to cell phone use or student attention and learning? There probably is. And that's going to inform how you generate your hypothesis and how you write up the background of your manuscript, because you're going to incorporate all the information that you find as well. Now, what does what I learned from the literature review tell me? What is it all? If I were to summarize it all, what does it tell me, and how does it inform my hypothesis? Step 3, we turn the idea into a research question. Now, this next step is asking a focused, researchable question. It's more than an idea. So, an example of that is, does smartphone use during studying affect students' attention and learning? Great starting point, right? We're getting closer. It's still broad. It's still exploratory, but now it's pointing to a relationship. So is this related to this? Now, students and researchers can sometimes or often stop here, but this is not yet a hypothesis. I serve on committees for dissertations, for folks' dissertations and master's theses, and this is often a challenging thing, because you have a question, but to develop into a hypothesis requires a lot more work to it. But what we can do is start to then identify from the research question the key variables. So before you can form a hypothesis, you must clarify what exactly you're studying. So in this example, we have a possible independent variable, smartphone use during studying, maybe notifications on versus notifications off. We have a few possible dependent variables. We could look at attention, we could look at learning, we could look at comprehension, we could look at test performance. And already the research question is becoming more constrained and more concrete, because to do a study, it has to be specific. Now, then we go to step 5, developing an initial hypothesis. This is your first draft. Now we're making a prediction. The initial hypothesis is still going to be a bit rough, but this is an iterative process. That's part of it. Students, our rough hypothesis in this scenario is, let's say, students who use their smartphones while studying will perform worse than students who do not, right? You see the prediction there. This is a real hypothesis. It's just still a bit vague. So, what do we mean by use? What does use mean? What does perform worse mean? Under what conditions? And really what we're getting to is that identifying use and performing worse, we don't really yet have a way to measure those. And if we don't have a way to measure it, then we don't have a study. So this is where hypothesis refinement happens. Now we refine it. We make it testable. Now, refining a hypothesis means making it specific, making it measurable, and making it clearly testable. So if we were to go into our example, our refined hypothesis, our strong version of this is college students who receive smartphone notifications while studying will score lower on a reading comprehension test than students who study without receiving notifications. So now we have a clear population. We're looking at college students. We've defined the population, we've defined the sample. We have a clear independent variable, notifications present versus absent. So we have two conditions for our study now. A clear dependent variable, reading comprehension test scores, right? And in this way, where there's no doubting, there's consistency. There's like one college student is not being measured on a literature test, and another student is being measured on an intelligence test. Everybody's being measured on the same variable, a reading comprehension test. And then we have a directional prediction that the scores are going to be lower. This is the final hypothesis. And now your study is partially designed. So in summary, what the hypothesis does and why it's so important is that it tells you what to compare. It tells you what to measure. It tells you how to design the study. It tells you what outcome to expect. And without a good hypothesis, a good strong hypothesis, you wouldn't know what data to collect, what groups to create, or what result would matter. So that's why hypotheses are so important. That's why operational definitions are so important. And why maybe you can see too that the specificity can be challenging, and that's why it can be really challenging for students. And so hopefully this presentation helped to clarify some of that. I'm always available via Canvas message. You can come by my office hours. You can set up office hours by Zoom to ask questions. I'm more than happy to walk through examples. If you have something in mind, especially for your final paper, that's going to be, that you're going to have to start thinking about soon, I can walk you through that. I have a fair amount of research experience under my belt. I've published a few studies. And so I know how hard this process can be firsthand. And so I want to be able to help in any way that I can. thank you all so much for your time and attention. I hope this was helpful, and I'll see you next week. Thanks. Bye.